In this video, we are going to be talking about a comparison of plastic waste fuel, biomass fuel, and petroleum diesel. As the world population increases, industrialization increases alongside it to allow for the maintenance of the population's current standard of living, creating a growing demand for a regular energy supply. Plastic waste fuel has proven to be a sustainable alternative, as it can be put into a pyrolysis reactor which creates an oil that is able to become a diesel substitute. It is also widely readily available. Biomass fuel can also be a sustainable alternative, specifically in regards to wood chips. Wood chips can also undergo pyrolysis to create a bio-oil as a substitute for diesel. To compare these fuels, we will be conducting a life cycle analysis, assuming that the end of life for these fuels occurs during combustion in an engine. We will begin by conducting an environmental analysis, starting with the global warming potential of each fuel. In terms of global warming potential from the production process, plastic waste has a significantly lower number than petroleum diesel and biomass fuel. The fossil fuel consumption of biomass fuel was assumed to be negligible, and lastly, water consumption for biomass pyrolysis fuel was minimal. Comparing these metrics, it appears although plastic waste fuel may be the most preferable due to its significantly smaller global warming potential. Moving on to emissions. As visually depicted, the environmental impact of these emissions are all similar. This is because when petroleum diesel and biodiesels are combusted, their emissions are in fact quite similar. However, since NOx has the highest global warming potential, we will use this metric to better quantitatively compare each fuel. Biomass pyrolysis fuel has the lowest value for NOx emissions, even when taking into account its upper standard deviation. Next, we will be conducting an economic analysis of these fuels, comparing their individual costs. The capital costs for plastic waste were about $1.52 to $1.85 million, whereas for biomass, the capital costs were $5.33 to $6.30 million, including the standard deviation. The capital cost for petroleum diesel is about $6 billion. However, these plants are producing a number of different products. When observing feedstock costs, it was assumed that the feedstock costs of plastic are negligible, as plastic is widely readily available. It appears as though the cost of feedstock for biofuel is in fact also nearly zero in comparison to the feedstock for petroleum diesel. Overall, it seems like plastic waste fuel is in fact the most economically feasible option. To conduct a social analysis of the life cycle assessment, we will begin by analyzing process safety through the comparison of the maximum temperature and pressure required for the production of each fuel. Biomass fuel and plastic waste fuel have similar maximum temperatures and pressures, as they both undergo pyrolysis. To maximize light olefins from crude oil for petroleum diesel, a much higher temperature is required of up to 899 degrees Celsius. Additionally, the pressure for crude oil hydrocracking can reach over 300 atmospheres, making petroleum diesel the least safest option in regards to process safety and making plastic pyrolysis fuel the most safe option. Next, we will be looking at the chemical safety involved in these fuels. To conduct this analysis, the safety data sheets were referenced for each chemical involved in the feedstocks and byproducts of each process. Each chemical was assigned a score to quantify its safety impact based on its flammability, physical hazards, and health concerns. As visually depicted, petroleum diesel has the highest score overall due to the fact that it involves refined crude oil, and plastic waste fuel has the lowest score. In conclusion, plastic waste fuel was proven to be most optimal. However, both plastic waste fuel and biomass fuel had much lower impacts environmentally and economically in comparison to petroleum diesel. Therefore, the government should incentivize investment in producing these fuels in order to create a supply. Investment can be incentivized through the presentation of all the research on these fuels, making it widely available to the public. After these fuels have been invested in and individuals have been convinced to switch over to a more sustainable fuel option, these fuels should be implemented as a transportation fuel and be mass-produced.